Hey, hey, hey. Hello, everyone. So, nice to meet you all here. My name is Alex. I'm from the Kaspersky Expert Training Team, and I'm happy to welcome you all here at our webinar on Windows Incident Response. I'll make a brief introduction and then pass the word on to our experts, Kai and Ayman, who will introduce themselves. So this webinar on incident response will consist of some theory, and a big part of it will be a live action. You will be able to watch Kai and Ayman doing live analysis with PowerShell on a compromised machine, and you can follow them on your machines if you want locally. So what we're trying to talk about, we're going to talk about today is just a fraction, actually, of what's covered in in our new course, Windows Incident Response, which is available on the Kaspersky Expert Training website. The training is very broad and comprehensive, but also accessible and well explained by Kai and Ayman, who are actually the authors of the course. During the course, you will master different analysis procedures. Ayman will have more details on them in a few minutes. The incident response training, like all of our other trainings, is heavily focused on practicing. So you will be working in a simulated virtual environment with all the necessary tools to practice incident response. Again, the address of our page is xtraining.kaspersky.com, and we begin. And be sure to follow the webinar closely, because in the very end we will have a Q&A session and a short quiz for you, where one of you will be able to win a free access to our new Windows Incident Response course. Thanks a lot. Ayman, over to you now.
Thank you very much, Alex. So let me start the slides, please. Hopefully you can see the slides, everyone, now. Okay, loading. I think we need to give it another second because it's still loading.
All right, everyone, give us please a couple more minutes. We're trying to launch the presentation, so bear with us. Thanks a lot for your patience.
Okay, I think it's better to share the screen. So hopefully you can see it all. Okay. Perfect. So thank you, Alex, again. And again, welcome everyone for our webinars today. So basically, our webinar will be about incident response in Windows environment. And in our practical part of this webinar, we will use PowerShell, the framework of choice for conducting live analysis of a compromised machine. This is how our webinar will go. So we will start with a small introduction about myself and Kai. Then we will discuss the incident response process in a very quick way through a block diagram just to review it with you. And then we will follow that with introducing our new digital or incident response course, online course from Kaspersky. And then we will introduce you quickly as well with the PowerShell and why it's important to know PowerShell and how beneficial will it be to use PowerShell in live analysis on a compromised machine. After that, I will explain to you the case study that we have created especially for this webinar, and then I will hand the microphone to my colleague Kai to go through the applied practical session with you. Then we will follow that with a question. It's like a quiz that you can choose the right answer between the several choices, and if you are lucky and you provided the right answer, you will have a free access to our online instant response course from Kaspersky. During that and after that as well, we will have a Q&A session where we can answer your questions related to this webinar, instant response in general, or even the instant response online course. So let me introduce ourselves to you first. So this course and this webinar was designed by members from GERT team. GERT stands for Global Emergency Response Team. GERT main responsibilities are to deliver incident response services, including digital forensic and malware analysis, to Kaspersky willing customers around the globe. We have experience in incident response for a very long time, many years. And one of the services that we started to deliver to our customers maybe like 7 years ago is on-demand courses. Whenever the customer wants to have a course or train their team on incident response and digital forensics, we have developed and delivered these courses to a lot of organizations and entities around the globe. Recently, we decided to have this as an online on-demand version as well. So our online incident response course was released recently for such purpose. So my name is Ayman Shaban. Myself with my colleague I will be your host for this webinar. I have been in the digital forensic and incident response field over 12 years, 8 of them with Kaspersky. I am now an incident response and digital forensic manager at GERT. Through my career, I have been handling incidents for different customers in different industries around the globe, as well as building digital forensic labs and developing and delivering forensic and incident response courses to different people, to different entities around the globe as well. Recently, I have published my book called Practical Windows Forensics, and now I will give the microphone to Kai to introduce himself as well to you guys. Kai, please.
Hi, Ayman. Thank you. Also from my side, a warm welcome to our Incident Response webinar today. My name is Kai Schuricht. I'm a Senior Incident Response Specialist. And actually to make we can say a long story short, beside all the DFR related tasks for different customers around the world, I also developed and provided trainings and workshops in the same field, and also design, conduct and evaluate tabletop exercises. So I'm and myself, we are looking forward to be the trainer for this online training. And that's all from my side. And Ayman, the stage is yours again.
Thank you very much, Kai. So The Kaspersky Incident Response online course. This course is all about incident response, right? And incident response as a service is a reactive service. Reactive, it means it starts whenever you have an incident, right? But it doesn't necessarily mean that you need to start the whole thing after the incident detection. One of the phases of the incident response is actually a proactive phase, which is preparation. In preparation, you need to be able to prepare your environment to be what we call the incident response friendly environment. You have your team trained, you have your own detections and monitoring techniques in place. You have policies, procedures, plans to be able to react to an incident whenever it happens. So all of that should be prepared before any incident takes place, right? So once you have that prepared, you will have a lot of alerts, a lot of events, a lot of detections, right? So you need to have a team that will be able to differentiate possible incidents out of these alerts, right? So in such a case, or in such a phase, we call it identification. You need to identify possible incidents, report it to the incident response team, which will be conducting some kind of verification and initial assessment. What does it mean, verification? Whenever you have an alert, you need to verify this is an actual incident, not a false alarm. Yes, there are false alarms. And you need to make sure that your resources, time, people, will not be wasted on a false alarm. So, and first you need to verify this is an actual incident, and then you conduct or you conclude an initial scope for this incident. So basically, if this is not an incident, it means that it was a false alarm. You need to adjust and tune your security controls in the preparation phase not to detect this alert in the future again, right? But once you have a definite incident, a verified incident, then you need to go forward to the next phase of the incident response process, which is containment. Containment, it's all about isolating and analyzing the scope of the detected incident. What does it mean, isolating? Usually whenever you have an incident, you may be able to, or the attacker may be able to laterally move within your environment, or maybe leaking some data to their CNC. So the containment is all about isolating the infected machine to prevent such post-compromise activities, right? So once you have that in place, you need to conduct analysis to understand the full picture of the attack, the whole components of the attack, and create a list of IOCs. This list of IOCs will be used in order to scan the whole environment in order to provide another list called a list of infected machines. So the output of this phase, the output of the containment phase, is all about isolating the environment, analyzing isolating the infected machines, analyzing the infected machines in order to have two different lists, list of IOCs and list of infected machines. In the next phase, you will try or not try, basically you need to do that. You need to eradicate all the infected machines by removing all the IOC that you have discovered within your analysis. So in the eradication, it's all about removing the list of IOCs from each and every machine in the list of the infected machines, right? To do that, you need to move forward in the incident response process to the recovery phase. In the recovery phase, basically recovery phase is opposite to what you have done in the containment phase. In the recovery phase, instead of isolating the infected machines, you need to recover the eradicated infected machines into production again to continue the normal operations of your work, right? But recovery is not enough. After recovery, you need to monitor the environment in order to make sure that the normal behavior of the network has been restored and the malicious behavior disappeared, and there is no other malicious behavior still exists in the environment. If this was not right, it means that there is no success in the containment and the eradication process, which means you need to go back again in the circle to the maybe eradication, containment, or identification phases, right? But once you have recovered the normal behavior of your environment, you need to move forward to the next phase, which is post-incident activities. Post-incident activities phase, it's all about understanding what happened, taking lessons of what has been affecting your environment. So basically, you need to have a meeting with every individuals or persons who were part of this investigation, asking yourselves questions like what happened, why it was successful, and how to prevent it from happening again in the future. Usually you will have a set of updates you need to apply to your environment to have a better security posture in general. So in such way, these updates will be applied in the preparation phase. And after that, you can declare end of incidents. And if you don't have any updates, you just need to declare end of incident and have this as a finished or closed incident within your ticketing system, incident response ticketing system. So this is a brief about the process. Of course, in our course, we have every phase in much details, explaining what needs to be done in every phase. So about our course. So the course is all about incident response. It was designed for security individuals and teams working in a very dynamic environments, experts who are facing cyber threats daily, and the course will be delivering knowledge for a successful incident handling and remediation as well. This is the roadmap of our course. Usually, or in this course, we are starting with some introduction about security in general. Incident response process will have its own part of the roadmap as well. And we also introduce you or give you examples of famous or major incident that happened. And it was published, of course, to give you an indication on how severe can it be if it happened in your environment. Then we will take every phase of incident response and explain it in much details. Then we will have different ways to verify and analyze an incident after detection in a system and network-based detections and verification. Sorry. After that, we will show you different ways to conduct evidence acquisition in a forensically sound environment. And then we will introduce you and give you some practice about memory forensics and log file analysis and network analysis as well. And we will end this course with cyber threat intelligence part, where we give you an idea about how to create IOCs in system level and network level using Yara and Suricata as well. So this is a brief roadmap about our course, which is Kaspersky Incident Response online course. So in this course as well, the full roadmap will be explained through a real-life simulated case related to a ransomware, a very dangerous ransomware that has been active in the wild. And we will cover theory essentials with IR process explained, of course, and practical exercises will be conducted in a complete analysis of the case study with tips all over the course from our previous experience in investigations as well. All the course roadmap, which will be covered in a real life simulated incident response or incident, will be through a real life environment. So usually we give you access to a virtual lab environment, Active Directory environment that we have created especially for such course, and you will have full access to the environment, conducting live analysis on different environments, collecting evidences from different servers and machines, and conducting analysis on these machines as well. So, and all of the analysis during this course will be step-by-step guided by Kai and myself as well. After the course, you will have a certificate of completion, of course, from Kaspersky. So, in this, or at the end of this course, you will be gaining a new skill through a practical challenge in virtual environment, understand the phases of incident response deeply, and know how to identify, verify, and respond to an incident on the cyber or in your IT environment. You will be able to differentiate APTs from other threats that targeting any low-hanging fruits on the internet, and of course you will be able to apply live analysis on victim machine that you have access to that environment all the time of the course as well. You will be able to acquire evidences of forensically sound environment and to do that in a real simulated environment. You will be able to improve your skills in memory analysis, cyber threat intelligence, and network traffic analysis as well. And of course, we will have a special log analysis topic in this course where we give you examples about the log analysis using regular expression and ELK stack as well. At the end of this course as well, we'll have in the threat intelligence part, we will have a big topic about creating IOCs, discovered IOCs. So how to create a list of IOCs using Yara for host-based and using Suricata for network-based IOCs. So maybe you are asking now, why ransomware case? Why you chose to have a ransomware case study for the course? Actually, based on the statistics from Kaspersky Incident Response Report for 2021, 33% of all true positive cases that we have received was actually related to a ransomware infection. So files have been encrypted using ransomware, which was increased by 5.4% from the previous year. So as you can see, it is the most and still growing threat. Not only from Kaspersky, but there is a statistic from FBI saying that the ransomware attacks costs around $140 million from different ransomware threat actors or ransomware campaigns, and this was published in RSA conference in 2020. So as you can see, the threat still active in the past 2 years and during this year as well. From what we are seeing now, from the cases we are handling, still very active as well. So now maybe you can ask yourself a question about your internal policy. If, God forbid, got hit by a ransomware, will you pay the ransom or not? Or maybe it's better to be prepared for such situation from now. Maybe you need to assess your security posture, create an instant response plan that will allow you to respond quickly and in the best way for such attacks. So if you'd like more information about our course, the Incident Response online course, or any other Kaspersky course that have been published already, you can visit this website and check the courses as well. So live analysis with PowerShell. As Alex mentioned, that we will conduct a practical session during this webinar talking about live investigation, and we will do that with PowerShell. So in this session, we will verify there is an incident using PowerShell and analyze the rest of the system artifacts using PowerShell as well. So why PowerShell? Usually PowerShell is a Microsoft command line shell and the scripting languages, right? It is included as an integrated scripting environment for scripting development, debugging by default in Windows. It is available since Windows 7, and it can be used for administrative activities on the local machine or even remotely in a remote machine. So even if you have two different branches and you would like to don't have the security control to conduct the remote investigation, you can conduct remote investigation and analysis on a remote machine in a different branch using PowerShell, of course, with the right and enough privileges for that. Now PowerShell is open source and cross-platform, so the knowledge that you have in PowerShell can be applied in different operating systems for live investigation as well. Okay, so how can we use PowerShell? As I told you, PowerShell is by default within your Windows boxes or Windows machines, but PowerShell is an object-oriented shell. So every object, everything that you can investigate, a process, service, will have a property, which some information about that object, and methods, which are some commands that you can apply on this object, right? So it's an object-oriented shell. If you would like to know more about any commandlet in PowerShell, you can just use get member commandlet, and for example, in this screenshot, we are trying to get more information about get service commandlet, And as you can see in the output, you will find some methods like closing and some property about the information about this service. For example, it can be stopped, can be shut down, can pause or continue. So these properties is actually information describing the object, which in our case, service. And the methods are some commands that you can apply on the object, which in our case is a service. So there is another way as well. If you would like to select some properties only to be shown in an output, you can just select specific properties from that object, like in our case here, service name, status, and start type, automatically or manually. If you would like to know or get more help about any commandlet from PowerShell, you can use get help commandlet and mention the name. For example, in this screenshot, we are getting more information about get process commandlet from PowerShell. You can update the help, of course, from time to time, or you can use # to show the same. And if you'd like to search for a term, you can just search it in using get -help commandlet. You can use or search for any term as per your preference. Of course, you can also open the online help from the from the PowerShell itself using get -help, then whatever commandlet you would like to search for, and then open it online using the -online option or property. If you'd like examples about any commandlet, you can use -examples for that. So it will give you examples about using of this commandlet. And this is an online help for PowerShell version 7, so you can open it and browse it and search for any commandlet there. Of course, commandlet has many, or PowerShell has many commandlet. But in this few slides, we will be describing some examples on how PowerShell can be useful for you. So if you'd like to record the session that you have with PowerShell in order to understand or remember what commands you typed before, you can use the start transcript command from PowerShell. And with this option, it will not be overwriting any file. So if this file is still there, it will be appending writing to that file. If you'd like to stop that, you can stop it with transcript. This is good because usually in incident response, you will be conducting a lot of activities, maybe stopping some services, maybe closing or stopping some processes. So maybe some of them will not be related to the investigation. So it's better to have like a record for that in order to revert unneeded changes that you have done in order to keep a good the production up and running without any interruptions. Or maybe you would like to remember the output of these commands as well. Get date is another command that you can show the date and time of this machine. Information about the host running the PowerShell as well can be obtained by get-host. And then if you would like to calculate the hash of a file, which can be, of course, important if you'd like to find if this file is non-malicious file or not. You can get that from from get-file hash commandlet. And of course, if you would like to verify the author of an executable, for example, you can use the commandlet get-authenticate signature, which is one of the PowerShell commandlets. Get hotfix give you the updated or the version of the updates installed on this operating system, Windows operating system. And of course, if you would like to copy files from one destination to another, you can use copy item, and remove item with another command that can be used in the eradication phase. For example, if you have a list of IOCs and you would like to remove some traces of malicious activity from a system, including some files, you can use remove item to delete malicious files from the system. And all the commands that you can use for eradication can be included in a small script, PowerShell script, that can be applied on a wide scope during the eradication phase. Of course, it will be applied on the infected machines to remove such traces, and you can do a lot within a machine. You can delete files, stop services, delete registry keys, and a lot of other activity that you can do during eradication phase as well. Git history will show you the history of command that you have done or you have conducted or wrote in the current session of the PowerShell. So again, if you'd like to check something that you have typed, it will be very helpful for that. Okay, so I told you that PowerShell have many commandlets. Some of them are related to processes, some of them are related to services, some of them are related to file system activities, and some of them related to network as well. So in these three slides, couple of slides, I will show you some specific commandlets in PowerShell that can be describing or analyzing. Firstly, processes. So get process is the most straightforward. Get process and show the output in a grid view. Grid view is an independent window, more interactive, that you can open the output in it. It will be even better for you to interact with the output, filter them, and a lot of other better viewing experience than the shell itself. If you'd like to select some specific properties from every process, like an ID, process name, path, start time, it will be you can pipeline the output from the get process commandlet and then filter the output based on these properties only, and you can pipeline that to the format table structure as well. If you would like to get information about DLLs and executable used or the image path of a specific process, you can use the get process and then the process name. You need to further investigate on it, and then get modules from the each or that process. Actually, it will give you all the DLLs and the executable image path of this process. Having DLLs will be very helpful in identifying the functions of, or maybe the behavior of this executable. If it will be using encryption at some level, if it will be accessing the internet at some point, or something similar to that. Then you can use the same commandlet in eradication as well. If you'd like to stop a process, you can just pipeline stop process or use the stop process commandlet directly with the process name to stop it on the live system. What about Windows services? Windows services is another big part of investigation. A malware can be starting as a service within the system, so you need to investigate services as well. So similar to processes, you have a get-service commandlet where you can show all the services, or you can filter only or the running services using this kind of pipelining with where object. Which will show only the status of any service that has a running status. And it will display the name of the service for you, because we are pipelining it with the select display name command. If you'd like to save or to set a specific status for a service, you can like pause it or stop it. You can use this command where you will be listing the service using the service name, and then set service status to be either stopped or paused based on whatever you'd like to do in this case. This can be for testing, if you'd like to know if this is a malicious service at some point, if it creates some kind of traffic, something like that, or maybe also for eradication phase, whenever you'd like to stop a service that is malicious. Also, you can just stop the service directly using stop the service commandlet, and you can force stopping the service as well. Or you can pipeline the stop service with the get service commands. Okay, the third part is registry. Registry is very commonly used for a lot of activities during malicious or incidents, like persistency, or maybe executing some code that has been stored in the registry value or something like that. So we have a command for that, which will show you the structure or the content of a registry hive, like in our case software here, and we have a format dash list pipelined by the output, because it will be showing you the output in a better structure of the output of the registry Hive content. Also, if you would like to remove a certain value during the eradication phase, you can use the remove -item property command for that, where you will be mentioning the value name and where it needs to be deleted. So this is a key, and this is a value that need to be deleted. In the network, for the network as well, you have 3 good commands. Get-net TCP connections will show you the current TCP connection in the system, and get-net UDP endpoint will show you the current UDP connections on the run live machine. And the last one is get-net IP address will give you information about IP or basically IP information on this machine from the PowerShell itself. For the file system, you can use get child item to browse different folders in the file system. Maybe you will need to get the access control or the security descriptor of the files recursively, of course, and maybe you will need to show only the path, owner, access strings, and the group of each file in the under C folder or C partition, sorry. And you can export the output in CSV. CSV is a very good for security people. You can use a lot of you can work around a lot with the CSV file. You can show it in a different format, command line or comma delimited file viewer. And you just provide the file where you will be saving the CSV exported file. In such case, I would like to get all the files under C partition that has a number, then followed by .exe as a name, right? Ending with exe. So where object, he means that for every object that will be listing under C partition, I need to find a file that has a name that matching a set of a number, then followed by .exe, which means that there is an executable named as a number, and I would like to have this in the list of the output that will be shown at an output of this executable. Of course, this can be the output of this command, sorry. This can be changing based on the circumstances of the case under investigations, but suppose that we found out that the malicious executable will be named under this naming scheme. So that's what we need to search for at that point. Then also we are searching for a task that had this kind of tasks under tasks tasks folder under system 32, select a string where the command had this kind of whatever match string you will have as a result of your investigation as well. So this will be also to check any persistency as a task, because tasks basically is an XML files under your file system. So you can check the files or the tasks as if you are checking a normal file in the file system. For Windows events, also there is a command for PowerShell called get event log, which we can use based on, again, on the circumstances of the case, but we have here some examples for you. For example, we are showing the newest file logs in the application and showing that in the application Windows events file, and then showing this in a format list view, or we are searching for security events, searching for event ID 4624, which is successful login, after get date, which will get the current date of the system, subtracting 14 days. It means that I need all the successful login events on this machine in the last 2 weeks, starting from current date today, right? So this is also will be very quickly showing you the structure, the events, instead of you going to Windows events or event viewer, filtering on 4624, and then filtering by time. So it will take longer for that. This also will show the Windows events. If you have a Windows event that is not default, for example, this is a Kaspersky event log, you can show this again with the Windows get when event dash path as well. The last thing that I would like to show you in get-when event is a filter hash table. Filter hash table is a way that Windows can use in order to show a pair of information like an IP or machine name, something like that. But in Windows events, it will show you this kind of filter hash table. It will give you information from whatever Windows events you would like to show. In our case, we are showing sysmon events where I need to find an ID number 1, right? And for each object, percentage here in PowerShell means for each object that was discovered from the earlier command, show property number 4, the value of property number 4, which is the image path of the executable, because event ID 1 is the process start event in sysmon, right? So whenever I have a process event ID 1, I need you to show me, I need the PowerShell to show me the path or the image path of the executable that started at that event ID number 1. That's it. It's a very quick review about PowerShell commands that you can use during a live investigation. In the next part, I will discuss the case scenario and suppose that during the kill chain, attackers will be executing a lot of different malware samples along the attack cyber kill chain. And after the initial compromise, in what we call post-compromise activities, they will be trying to collect data to laterally move within your environment, jumping from one machine to another, and maybe harvesting extra high privilege credentials from the system once they have an initial compromise or initial foothold. So for our scenario, suppose that there was an alert for a web domain access that was triggered from one of the machines in the environment, which was reported to the incident response team. In this part, we will need to verify that the activity is malicious. And once we verify this is a malicious activity, we will conduct some live analysis on the compromised machine in order to get more information about such attack or about such malicious activity in such case. And of course, we will use only PowerShell for this practical exercise. And this is time for me to give the mic and the stage for to Kai to continue the practical exercise from his part. Kai, please.
Thank you, Ayman. So I will share my screen. And so hopefully you can now see my Windows operating system. And yeah, so we learned so far some commands we can use for PowerShell live analysis to find out what's happened on the potential compromised system. However, in that case, we got informed that there was a network connection or a connection to a domain, and we need to find out what process caused that connection. And so from that, we will use now PowerShell for to find out what happens on that particular system. So to start working, we can follow different approaches. First of all, we can just type any commands we just learned so far, based by Ayman. But another approach might be also is a more convenient way, because as we have seen with the Microsoft Windows sysmon operational event ID and with all the filter hash tables with properties, maybe we have some more properties rather than one. It takes some time to write the whole command in the PowerShell session, as well as there might be a good chance to have a lot of typos. So from that, a good approach is also to have what we call it's a kind of PowerShell model. That means it's a kind of model we can use to define some function, and during our engagement we just import the module, and then we can just directly launch our function to get the encoding information. So for instance, normally a typical approach is first we need to import that model into our system. I have this here under the sec folder, and with the parameter -force, we mentioned in case it was already imported to the system and maybe we have done some additional changes and we have to re-import that model again, then over the parameter force, the currently loaded models or functions will be replaced by the latest versions. But to find out if the import was successful, we can launch the command get command IR, because all the functions start with IR, as you can also hear, for instance, with the get host info, and select only the name of interest. And here we can see all the functions we have defined in this PowerShell module to work later during this incident investigations. Okay, so normally or a typical approach that might be relevant is also, first of all, to get an understanding what kind of operation system we are dealing with, as well as some other interesting information, such as what kind of OS we have, the version, the install date, when was the last boot up time, as well as, very important, is the current PowerShell version we have. As we have seen, PowerShell is available starting with in version on Windows Operating System 7, and starting from that, we have a lot of new commandlets have been introduced, and of course, some commandlets are not available in older versions of PowerShell. So from that, we need to know what kind of PowerShell version we have. That is here in this case PowerShell version 5, and we also see that sysmon status. That means here we have also sysmon event logs running on that operating system. So what is actually behind that function? This is something we can see here. The function consists on several PowerShell commands. So first of all, we ask the WMI class, that means Win32_operation system. And from that WMI class, we select the OS, we select the installation date, last boot up time, current date time, and we use the calculated properties to also add some properties from other WMI classes. For instance, here, the computer system, here we want to have the current time zone, and also we include here the get host command, and we are interested here only in the version. And finally, the get service, the command we already learned so far, is to find out what kind of services we have running on the system. And with the where object, we filter for the display name sysmon and request the status. And with the result, as we can see here, we have all the most relevant information at one view, and there is no need to run several commands step by step. So, but actually, it's up to you how you would like to start your investigation. This is one approach that might be also maybe convenient for you. However, it was told that we have a strange network connection, so we have to find out which processes or which process, or maybe we have several processes, caused that issue. So from that, the first command we can launch is a kind of, it's a function that is called get process triage, and what actually that process, that function is doing. Just have a closer look for that. It's just searching for the WMI class processes, and we are interested in the process ID, parent process ID, also the executable path, the command line, and also as an additional benefit, we also use the calculated properties also once we received the executable path, also to calculate from that the encoding hash, so that we can easily find out what's going on. And also we filter out some other executable path that might be not relevant in the first stage, but sure, everything depends on the case and the investigation. However, in that case, the kind of triage approach, we'll see our process is running, and we also see here a strange process running from the document folder, which is called msdcsc.exe, and we also see the start time. We also see the process ID as well as the parent process ID. So maybe that also was the process that caused that network connection, and when we are lucky, we can close our investigation. However, to find that out, we can launch the commandlet get-net TCP connection with a parameter owning process, and we filter for the process, what is 4756. And as it looks like, no objects can be found. So it means here we don't have any active network connection related to that process, or maybe it's not the correct one. However, we can also check if there are any other processes, network connections running in our system. So from that, we use the function ir-get-net-tcp hash. And to make it more convenient for us to read the encoding output, I type the output of this function to the format table with the parameter autosize and wrap to see or to receive a more convenient way. And based on the size of the PowerShell here, to make it more convenient for you to reading, it's a little bit strange here to the view. However, we see the creation time, remote address, remote port, owning process, also the file name. Again, here we use the calculate properties and the encoding hash. We can also see which process and with the encoding or which process ID with encoding file name and hash created in a certain network connection. And as it looks like, we have someone, but currently not the one which might be relevant for us. However, to find out, excuse me. However, the question also came up, which other process started this strange processes we have seen before? So let's go back to our get process triage. And here we have seen the parent process ID. So it means which process start this suspicious and strange process. So for that, we can use the get WMI object win 32 processes. And we say select process ID. Parent process ID. Let's first look if it's working. Perfect. So, and we are interested in the execute. Executable path and command line. We are object. Process ID, and here we have to select the process ID we have seen before. That means here the parent process ID, and so from that is like, what was it, 706 as far as I remember. And here we can see sometimes we have some typos, and here we can see that strange process was started from the win logon process. And actually that means as soon as someone logs into the system, here other processes got started. In that case, here our strange process. So that also means it needs to be written somewhere. That means, for instance, in the Windows registry. So from that, we are lucky that also the Microsoft introduced a very interesting event log that is called Microsoft Windows Shell Core. And using that or passing that Windows event log, we can track for process executions that are launched from the run or run once key from the software Microsoft Windows current version. And to do so, we launch get shell core run. This is the function that is just traversing through this Windows event log. And here we can see based on the time, Okay, here we have our strange process again, our msd.csc.exe. So it means here it was launched from the software hive, and now the question came up when this registry key was updated or something was inserted to that. However, there's something we need to find out. So actually, though we haven't seen any network connection that caused the alert on the firewall, however, we see here now a strange process, and that is also seems to have a persistence entry. So from that, we need to step, or we have to go ahead with our analysis to find out what's really happened on that system. Okay. So the next step is we have seen our sysmon process was running. So from that, we need to find out what is the current configuration that was used to start the sysmon process. And so from that, in case to find out where the executable file for the sysmon.exe program is, we can launch the WMI object command win32 process, and we define select object. We are interested in the executable path. We are object, and we are interested in again in the property executable path, like sysmon. And let's have a look. It looks good. So this time the command was typed correctly in it. And now we can make the use of PowerShell again to launch that executable directly over the sampercent and executable path -c. And now we receive directly the whole configuration that is used or configured for that particular system. So from that, we want to see, for instance, are there any registry settings defined for that, as we can see here, for instance. Or what else do we have here? So we have a lot of definitions. And here we also see current version run, Policy Explorer run, and all this stuff. So from that, we can check right now when these entries, because we have seen this from the Microsoft Windows Shell Core event log, that something strange was executed from the Windows registry. We need to find out when this happens, because we need to find out the time of the incident of that. So what we can do for that, we launch the get sysmon registry activities, and where object is message like, and here our strange process in question, msd.csc.exe, and we type this into the format table auto sites, and hopefully we will find the encoding entries which we expect to see. Here we go. So what we are seeing here, based on the event ID from the Microsoft Windows Sysmon Operational, we see that time created at that timestamp. We see quite interesting things. We see another strange process, system.exe launching from the temp directory of the user account aligner, and that seems to create it or to add the msd.exe to the user init.exe. That means here, actually, here we have entries that means that once someone logs into the system, that program user init.exe normally will be executed to retrieve user profile information, but also we can expand other programs. In that case here, it seems also msd.exe was added. And another interesting value here is that we see the system.exe also added the same path. So you can see here to the current logged in user profile. So for that, for this user profile, and that means here for Aligner. So it means here also once Aligner logged into the system, then also that exe program will be executed. So that is definitely very malicious. And so from that, first of all, we can say, okay, well, we haven't seen any network connection so far. However, we have seen our malicious process, and we have seen that here this also is persistent on the system on 2 locations. So now, as we have seen, sysmon configuration have been applied. So let's have a look what's happened during the time of the incident. That means here from that time on our particular system. So from that, we can use the next function that is called ir-get sysmon. And we are interested in all the IDs. So that have been recorded during that time. And what's happening in the background? So that function actually is just traversing through the Microsoft Windows Sysmon operational event ID, is doing a kind of group objects and also the encoding count of it. And we also have an additional lookup in the background of this function to retrieve the encoding translation of it. So how does it look like? We can also have a short view of that. Oops. Yeah. Let's try it again. Now my search, where is it? For any reasons, that's live. Let's open it again. Now we got it. Okay, so what actually that command is doing, we use our filter hash table, and that is built up from the parameter we have seen here. The parameter start and end time is an optional one, and then we use the group object ID, select object, the count, the name, and then we use again the calculated properties and an additional built-in function, or we can say kind of array lookup, to translate for each event ID the encoding text description. So just to make it easier for us to find out what is really behind one event ID in case of an emergency. Sometimes we don't know what event ID is, for instance, 17, and then we have all the description to it. However, so now one benefit, as we can see here, is that we also see DNS events. So this is something we have been looking for. Again, we are still searching for what kind of process created the strange network connection we have seen. So from that, we can use the commandlet get bin event, and we use the filter hash table, and we define the log name equals, that was the Microsoft Windows Sysmon operational. Just to check, okay, no typo. And then we are interested in ID 22. And pipe everything format, oops. To see here any network connections. And as you can see here, it's not so convenient to work with that approach, as we are interested in, for instance, here in the query name, and we also want to parse for it, and also to find out how many times, for instance, that query name was requested. So from that, we have to use the filter hash tables in a more convenient way, as we have seen before in the slides. So as we have seen, we have in this event log, the event data area, and these information are needed to find out the encoding position of encoding properties. And in case we don't know what kind of properties we are looking for, we need to find that out. And one approach is, let's do that in that way. We know we are still interested in the event IP 22, and we just define the max events 1. That means here we just want to have only one entry, because we want to find out what is the structure of the whole message, and we define that in a variable event equal. Let's have a look. Okay, now we have the data here, and now the next approach is to convert this into the XML format. So that means here XML and event and to XML. That looks good. And then we just need the whole data. That means here event data.data. And now we see what are the encoding data areas we have here. So it means here we have the rule name, UDC time, process, global unit identifier, process ID, query name, status, query size, image user. And as we know from the programming, each area starts with the value 0. So once we are interested in the query name, we select 0, 1, 2, 3, 4. So it means our properties 4 we are interested in, and now we can expand our query. So events are not needed anymore. And the next step is that we here now need just to use the select object, and we are interested in the property, and first of all time created, as we are still interested when something happens, and we now time created, comma, and we are interested in label. So we give that new calculate property a name. We just keep it the same, query name, and the expression is the properties for value, and hope I don't have any typos. Now looks good. And now we can also expand it more. That means here we are interested in the group object and query name, and now everything will be grouped as a result. However, as you can see here, we still see a lot of other network connections during different times. But as we already know the timestamps of the happening, I use my query, my function again, ir get sysmon DNS query. That actually is doing the same as we have seen before, just defined as a function. And I only define here the time of interest. That means that one, and group object query name. And as you can see, the view is not the best. So let's just pipe this in the out grid view. And now we have much better view. And what we see, we have our two strange network connections. One is created from the mstc.exe, and the other one is called, was initiated 1 second before from another strange program, our server.exe, what we actually have seen before. So from that, we have now our strange two processes with encoding DNS query, and now the next question came up because here server.exe seems to be the first one. So we'll find out when this server.exe program was created, or means when it was executed the first time. So for that, we can use our, or can pass our security event log. We filter for 688, and I just copy the same date here. We are object, and we are interested in the pipe object message, like server.exe. And let's have a look. Okay. Or maybe also have another time. So now let's investigate that further. Format, table, auto sites. Whoop. And we have a lot of information here. Luckily that we only have seen some output before. That was only something about 10 entries. So we can just easily scroll up. And once we have done this, let's have a look. We always see all the time something with SVC host and our RSR server.exe. So that is not the server.exe we searched for. So maybe I have to change here the query somehow. However, quite interesting. We see here our server.exe and created process name, something from file.exe. Very interesting. Now it's getting a little bit more complicated. We have a new file of interest, file.exe. So from that, I think it's now time to check or to filter the sysmons for any files that have been created during the time of our incident, because when we have a look as well, everything occurs during that timestamp. Okay, so how we can do that? IR get sysmon, and we are interested in file created. And I hope, no, I don't have that still in. So maybe the next time we can just open the additional editor to have that somewhere for easier copy paste, however. And out grid view. So what we are seeing here, all some other strange activities, I guess. As you can see here, we see that PSExec was executed, and it also seems that based on the time, a file was copied from somewhere else to that location. That program launched a bat file, also another file.exe. So we have now here an additional IOC, and file created a system.exe, file created server.exe, and let's have a closer look. What else do we see here? And system.exe created msdc.exe. That is what we already have seen. But we also have another finding, mpv.exe, and also wbp.exe. So a lot of other programs have been created. So what we can do is we can now create a kind of IOC filter to find out, are these files still present on the file system? So what we are doing in such a case, we create an array. So that is called, let's say, bad files, and equals, and we call it pv.exe What else? mespv.exe. What else? wp.exe. msdcs. Now I got it. Server.exe. System.exe. File.exe. Okay, looks good. Let's just check if we have everything there included. Oh, okay, great. And now we can filter from the file system. We can do it with the same commands as Eamon provided us before. However, we can also use the encoding function for that. That means file system listing hash. So also, as the name suggests, besides the listing of the directory, we also receive the encoding hash of the files. So that means we are interested in users, aligner, app data, local, temp, and where object, our previously created bad array files, bad files, contains our pipeline object name, and as it looks like, we only see these two files are still present on the system. It seems that the other one we have in our bad files are already deleted. However, what do we know about that programs? As we know, also there's a good Sysmon event program or event filter available for process creation. We'll also make use of that. Because one benefit of that is also we see the encoding command line parameters that maybe have been used. What was it? Process creation. And what we also see here, we also see the encoding command lines that have been used. And also, we see some additional IOCs, and also one benefit that is really awesome is we also see the original file name. And as you can see here, for instance, system has another original file name, but here we see that wbp.exe has original file name called web browser passview.exe or mspass.exe. And as it looks like that that programs stored and result into a txt file. So it means here, it looks like that here also some credentials dumping have occurred for mail and browser. And that actually, it's really very suspicious, and that needs to be investigated further. So from that, what we are doing now, the next step might be to isolate the system and to conduct a full forensic investigation. Maybe we have all overseen some other artifacts. However, still question remains open. That means here from which location or the PSExec was executed. And so from that, we can use our last function for that day. That is the IR get security logins. And here in such case, we are also interested in where object log on type equal 3. And as I believe here, what you will see here behind that, we also use the filter hash table with encoding properties. And here, mostly when something happens on the compromised system, something was ready to network login. That means here log on type 3. And let's have a look if we also see some activities here and if they are also related to the time of the incident. And here we go. We are lucky, or maybe not, depends on the point of view. So we see at the same time and remote login was conducted from that IP over the victim account aligner. So definitely we have to start further, or we have to continue our investigation to see what happens on that particular system. And now we can easily see what happens. Only what we just received that a network connection to a suspicious domain have been seen on the firewall or have been blocked or whatever. It might be sometimes also relevant to investigate the system, what's happened. Maybe here not only one system is compromised, but also maybe the whole infrastructure. But this is something we have to investigate it further. Okay, so also from my side, a long story short, this was a short introduction about how we can use PowerShell to work on, as well as how we can combine PowerShell modules and functions to make it more convenient for us to work on that. And in such a case, I will now forward the mic to Ayman again, as he also has the PowerShell screen open, as I guess.
Thank you, Kai.
What can we?
Yeah. Hello. Thank you, Kai. Can you hear me, right?
Yes, I can hear you. So we can also use the slide button, or maybe as we had before some problems, I think maybe it's better if you just can go ahead. It's okay?
Yeah, it's okay.
Perfect.
Thank you very much, Kai.
Just to avoid that, you're welcome.
No worries. Thank you for the very nice session. It was very detailed about how we can use PowerShell in such purposes. So let me share my screen now. Let's go through the slides, the stop slides very quickly. So what Kai mentioned now is only, or what Kai did now is only part of what we have in our course. So in the course, you will have a complete ransomware case. You will have a live Active Directory environment. You will have the Active Directory, SharePoint server, and other machines within the environment, which you can fully use them for your investigation. Track traces in different machines, and we will complete the roadmap of the course because what we have done now is just a small part of the roadmap of the course, where we conducted incident verification and the analysis on a live machine, which also we use live analysis technique in the course, but we use different other techniques along with the PowerShell, including IRCD as well. So this is the whole roadmap will be completed in the course in a different case study, not the same one we used in our webinar. And this is a time for a question to you. This question, the right answer of this question, will have the chance to win a free access to the incident response course, our online Kaspersky Online Instant Response course. So please try to, answer this correctly. So which of the following commands, PowerShell command, will generate this output? This is an output we have generated on Alina machine with one of the following commands. This one, this one, this one, or that one. What we need from you now is to identify which of these commands will generate this output. As you can see, we highlighted the differences between this command, which is property numbers of the event for 624. So we will give you some time in order to try to find the right answer of this question. And meanwhile, we can just discuss your question that you have for this session. So to moderate this, I will be giving the stage back to Alex. Alex, please.
Hey, yeah. So to answer this question, the questionnaire Ayman has provided, please go to the polls section on the right. Click on the polls, and there you will have a 4 variants. So find the polls button and press it. There you will find 4 options, all the questions, and choose the right one.
Of
May not
course,
be
Alex,
actually-
they just need to mention the number of the right option, right?
Yes. So just click on the number that corresponds to the correct answer on the slide. And I think we will give you about 5 minutes. That should be enough. We'll launch a countdown. And while we're on that, please also ask your questions. That's a Q&A after all. Ask your questions and I will pose them to the speakers. Just give me a second. Alrighty, so we're on the questions. Where is it? Again, it may be your interface may be slightly different from mine. Look at the bottom of the screen, the polls button or the icon. Just hover over it, and you will see the word polls. And there, just choose the number that you think corresponds to the correct answer. So, guys, if we are ready to answer the questions from our viewers, from our listeners, so let's begin. Sysmon is not very common in real incident. If you don't have Sysmon, what do you do in these situations? Thanks.
Okay, this is true. Kai, would you like to take this?
Yeah, I can take this
please.
question. Thank you very much. Yes, actually, it's not very common, but what we have seen that it is installed more and more often on server systems, because just to find out what's really happening on the system, and in case it's not installed, then of course we have some limitations. But actually, as always, we have to think about what is already configured on our system based on the security audit policies we have. Think about on the first stage what I mentioned regarding the preparation step. We have to think about what we need to have enabled to see the encoding incidents on our system. So at least we could see for 688 event, process creation or login event, but also we could see upcom cache or activities, or we can see file creations during the timestamp. And of course, if we don't have this enabled, the service enabled on the system, then of course we don't see so any artifacts, but at least maybe we are able to find out at least when something has occurred on the system and what other files have been created based on the master file table or change journal or any transaction log files, etc. Everything but actually depends on the configuration of the system itself. I hope that answered that question for you.
Yeah, thank you very much, Kai. And just I can add that the native audit policy of Windows is not that inclusive. So people are either use Sysmon, as Kai mentioned, or maybe use an improved audit policy for Windows to enable events like new process started, file accesses, as Kai mentioned as well. So you can use this as a lesson learned from this webinar to search and find a better audit policy for your environment, or try to deploy Sysmon on maybe if there is no way to improve it, to apply it in a wide scale of your environment, you can just apply them on servers, important servers, for example. So just type it as one of the lessons learned from this session. This is one of the goals of this session, to give you ideas about better incident or better security posture in general, and better incident response for future possible incidents. Thank you very much, Kai and Alex. Any other questions?
Yeah, sorry, I was on mute. How long does it take to complete the course?
I think with the current criteria, it depends on your base. You have only access limit for the environment, but you can just access like 2 hours today, 3 hours the day after. But I think the current criteria is 100 hours in total. So you can use them as depend on your availability, and this is one of the benefits of the on-demand courses, that you can have your own pace of the course. Alex?
Yeah. Hang on a second. There's a question. What is it? Could you please specify?
Yeah. Take your time.
And so, meanwhile, we can continue.
The counter is counting, right? For the question?
Yeah, there's something beeping in my ears. Headphones. What are the ways we can differentiate APTs from other threats?
Okay, so APT can use different other sample. That the first way, of course, if you discovered a brand new sample that doesn't have any signature in any way, this can be a good sign for an APT. But an APT is a major compromise for a long time within your environment. They have been within your environment for some time. They are digging deeper within your environment, jumping from one machine to another, harvesting extra credentials all the time, leaving backdoors in every accessible location from your environment. We have seen APT that has been within or compromising the environment without detection for years, like 4 years, for example. So usually the type of analysis is different, is the same, but the indications of compromise that can give you an insight that this is not a normal executable that has been downloaded by mistake from the internet or something like that. It has been something that intentionally targeting your environment, and because of you don't have any traces of the malicious executable that has been discovered, you don't have any signature for them any other way, any other place, it means that it may be targeting your environment specifically. So it will be appearing during the investigation, and we will show you that in the course as well, because structured analysis led by findings. So, as Guy mentioned in the practical part, you will have to jump to another machine and continue the analysis, right? This structured investigation led by findings, actually will show you that these traces are there for some time, and we will discover different malicious activities and malicious executable every time you conduct analysis. So it can give you a very big hint that this is an APT, especially if you find an IOC that matches another threat actor or another campaign, which you can find from your threat intelligence feeds as well. I hope this answered the question at some extent.
Yeah, thanks a lot. I suggest taking one more question and then moving on to the results of the polling.
Sure.
When you have a malware in the system and the hash is not in the VT, what do you do? Do you have analysis by this time? as far as I can. So what do you do?
Very good question. So you have an executable that doesn't have a signature. You don't find the hash anywhere in the public threat intelligence, like PowerShell or something like that. And what is the next step? We usually recommend to start your analysis right away. So you start your malware analysis, incident response process if you have one, and try to analyze this piece of malware in-house. Or using your retainer, incident response retainer, but uploading this file to different websites like VirusTotal can be having bad consequences. It can include some sensitive information. So once you upload it to VirusTotal, it can be downloaded by someone else, and it can alert the attacker that you have discovered their executable, therefore they will change their TTPs. So it will be even harder for you to detect them. So if you have a suspected / malicious file that has been discovered within your environment, the best thing is to do is to analyze it with your internal team or using your retainer incident response or incident response retainer, provider, incident response provider. So in such a case, you will be 100% sure that whatever discovered on this file will not be leaked or known by the attacker or leaked to someone else. I hope this answers the question as well. Alex?
Okay, Kai, thanks a lot. Now, relax, sit back. We're about to announce a winner, or should I say we're about to define a winner.
Okay, perfect. Should I, did we stop the time for providing answers? Should I give them the right answer?
Yes.
Okay. So after that, I will give you the stage.
Yeah. Yes, and you can comment on why the answer was correct, if you have anything
sure.
to add.
No, sure, no problem. So so in every event, there is some properties for that event, which differs from one event to another, right? 4624 have a set of properties, and each property have a piece of information, like the username logged in, because 4624 is a successful login. So you will have property that will hold the username, property that will hold the source IP of the access, property that will hold the login type, a login ID, login session ID. All of these are structured in what we call properties. So in our question here, we are giving you different properties numbers, right? So what you had to do is to try to find the right properties that, for example, that will show you the time of this event, then the username accessed, then the login type, and then the source IP of the access. And the right answer for that is answer number 3. So to show such output, you need to show property number 5 followed by property number 8 and then followed by property number 18. And of course, we are showing time created as a way to show the filtered properties. So in such a case, I think I will be giving the stage to Alex to announce the winner of the free access of the course. Alex, I will stop sharing my screen and give you the mic, please. Alex, maybe you are muted.
Yes, I'm on mute. Ready to share my screen now.
Yeah, please.
everyone. We have 9 people who gave a correct answer. And let's do a very simple lottery. So we have numbers from 1 to 9. Here are the names. You can see them live. And 3, 2, 1, go. Number 2. My congratulations, Ari Prianto has just won a free access to our Windows Incident Response course. My congratulations. We will get in touch with you via email. Hope this is a good news. So that's it, actually. It's very quick. Guys, you're on mute.
Yes. Yeah, congratulations, Ali, as well. Hopefully it will be beneficial for you, this course. And,
Absolutely, yeah.
I think that's it. Thank you, Alex, and thank you very much, Kai, for the practical session as well. Alex, anything else?
Welcome.
Yeah.
Well, just want to thank you guys for this amazing webinar. Kai, Ayman, always nice to work with you. And to our viewers and to our listeners, to participants, thank you very much for taking part. We hope that this is a really useful event for you. We try to make it informative and useful. Hopefully, we can see some of you on our other webinars that we're going to host in future. And if you're interested, you can always go to xtraining.kaspersky.com to choose either this Windows Incident Response course or several other courses that we have installed. So thank you very much for participating. Thank you guys for delivering this training today, this webinar. And goodbye.
Thank you, Alex, and thank you, everyone.
Goodbye.
Goodbye.